Hello student, welcome to today's session. So the today's session is again in continuation with the organic reagents. So we shall be discussing one more problem today in regard to this reaction sequence where some reagents are being given. So we shall be learning some of the reagents as we done in the previous video also through the problem solving. So what is being said in this particular question, you have to figure it out the incorrect statement given in these four options. So first, the starting material is what you call it as acetylene, which is a alkyne, and this is being treated with sodamide or potassium amide. So let us discuss one by one every aspect of this. So potassium amide or soda amide, basically these are the source of amide ion, and amide is a very strong base. This is a very strongly basic species. It is a very strong base. And what this strong base would do, this would do the deprotonation. So it would abstract the H positive from here, and as a consequence, if I have two moles of it or two equivalents is being mentioned here, so it will abstract from both sides. Why is it doing so? Because this carbon is sp hybridized, and the electronegativity of sp hybridized carbon is more. So electronegativity of sp hybrid orbital is greater than sp2 than sp3. As a matter of fact, this terminal alkynes are acidic of not so acidic because their pK value ranges between 24 to 25 depending upon the groups attached to the triple bond. But make it a point, out of all the hydrocarbons, we will say that terminal alkynes are fairly good acidic provided they happen to react with a very strong base like sodamide. So here what you get a carbonyl type of a species along with two counter ion as potassium, and these carbanion, which may also be written like this C22 negative, or this now would attack the alkyl halide, that is the second part, and this negative part as a nucleophile would attack it because this is delta positive, this is delta negative, and this in a way is a sort of SN2 reaction, nucleophilic substitution reaction is happening. Since they have given the two moles, so this part also would attack it. As a result, it would result in the formation of a sort of non-terminal alkyne is being generated. Non-terminal alkyne has been generated. So beautiful thing by which you are able to understand from how do we convert a terminal alkyne into a non-terminal one. So this is in a way a one of the ways of making higher alkynes from the starting material as acetylene. So moving on to the next part. So we are through the A option, that what A is. A is nothing but butane 2, but2-ine. So this is what we have got. Now moving on to the B option, where you are treating it with a hydrogen in presence of Lindlar's catalyst. So here you have to remember that hydrogen in presence of Lindlar's catalyst is a reagent which is used for doing partial reduction of alkynes. So now this is a reaction of alkyne coming in front of us. So partial reduction is a way by which you would want this term. Otherwise, what would happen if you treat it with hydrogen in presence of nickel, platinum, platinum without adding Linda's catalyst? So what it shall be doing? It would not stop the reaction at double bond state. It will take it to the alkane stage. So hydrogen in presence of Lindlar's catalyst would take this reaction to double bond only, and that too to it would generate a cis alkene. Cis but 2-ene is generated. Now here I would also like to mention here what is the composition of Lindlar's catalyst. It is platinum spotted on barium sulfate or calcium carbonate and is being poisoned with quinoline or boiling sulfur. Poisoned with quinoline, or this whole composition makes what you call it as Lindlar's catalyst. The poisoning is done so that the activity of the catalyst, the adsorbed hydrogen on platinum get reduced, so that otherwise what would happen, this alkene which we have got would further get reduced to alkene. So we would restrict it to the alkene. So the poisoning of catalyst is required for that matter. And another, so in although it is not being mentioned and not being asked in this particular question, but I do add few things more while solving this particular question, that you can also use hydrogen in presence of nickel boride. This again is called as P2 catalyst. This also convert it into cis alkene. And another one, which is a reagent sodium in liquid ammonia, this reagent is named as Birch reduction. This would convert a triple bond to double bond, but this double bond is of the type trans. This is very important. This would give you trans alkene. So the stereochemistry part is important in this, and in some other video I will explain what is the mechanism involved in all of these reagents. So at this point of time we are just touching what are the data available for reagents and how they are going to play in this sequence type of reactions. Now moving on to the next part. So we are through this part also. This we have generated. This we got it as non-terminal alkyne, and this we got it as cis-butyene. So we happen to get is as cis-butyene. Now cis-butyene is treated with ozone in presence of zinc. So this is a reagent for ozonolysis, and ozonolysis is of two types: reductive and oxidative ozonolysis. But ozone in presence of zinc water, when is given, it is a step which has to be taken through the reductive ozonolysis. So tip to remember here is, whenever you come across this reagent in front of you, what you have to do is you have to break the double bond from the center. Double bond is to be broken it like this, and you have to place two oxygen in between the double bond, as simple as that. So this is a simple, otherwise the mechanism involving how this has happened would take good amount of time. So at this point of time I'm placing some facts and figures in a simple way. So now you have got butyene, cis butyene, so it is being ozonized, so it is to be broken like this. So you end up getting what you get in this case is acetaldehyde, or you may say ethanol. How many moles you would get? 2 moles of this is being produced. At times this question is asked in the reverse way also, that if you want to get ethanol from ozonolysis, which starting material you should take. So you should be taking butyene. That is a different story. It can be cis or trans. Both of these would give you ethanol. Now once you got ethanol also, now what is to be done? So this we got as ethanol, that we got this particular compound as ethanol. Ethanol is now treated with NaOH. Oh, beautiful. So now what is the role being played? So whenever you have any aldehyde or ketone, and that aldehyde or ketone is having alpha hydrogen along with it, in the alkaline medium, if it is being taken, this would direct the reaction towards the aldol condensation. For this particular thing, lot of videos are available in DCD playlist. You can just refer to that, aldol condensation. If a given aldehyde and ketone has a alpha hydrogen and is being taken in alkaline medium, it generally adopt aldol condensation mechanism. And if it doesn't have any alpha hydrogen, then in the alkaline medium it can take the reaction through the Cannizzaro reaction. For that also some videos are there onto the channel in the DCD playlist, Cannizzaro reaction. So now what is to be done in aldol condensation? Simple tip to remember is that you take the 2 moles, because you have to condense them together, so you need 2 moles of it. Just place the alpha carbon hydrogen bond in front of CO of the other molecule. Just place them together in front of each other and just join them together like this. This is the simplest way to make the aldol product. Not going into the details of the mechanism and things like that, you would get this answer. So what the aldol condensation, how is it is to be done? Take the molecule, if it is having alpha hydrogen, place that two molecules in front of each other in such a way that the CO of one comes in front of alpha carbon hydrogen bond of the other, and then join them together the way I have shown. So what you happen to get in this particular case is, this is aldehyde, and this part which we got is nothing but alcohol, ol. So you end up getting aldol. So we got an answer also, that here the D option is this moiety. So you have got aldol. And now as a matter of fact, what exactly is aldol? Aldol is nothing but alpha beta. So this in a way is beta hydroxy aldehyde, beta hydroxyaldehyde. So now let us check the options available to us. What are the options available? So the A option is beta hydroxyaldehyde. Yes, it is a right statement, and which would not be our answer because we are looking for the incorrect statement. And B option is A is a non-terminal alkyne. A is a non-terminal alkyne. Perfectly right. This also is a correct statement. And C option, C is alkanol. Alkanol means it's a IUPAC name of aldehydes. So it is ethanol. This also is a correct statement. And the last option, D option, is B is a cis alkene. Cis in it is a cis alkene, but now the thing is, now the question is very tricky. If you have gone through the options very casually, you would miss one thing. So here it is written as unsymmetrical, but this particular alkene is symmetrical. This is cis symmetrical alkene. Now what is the difference between symmetrical and unsymmetrical alkene? Symmetrical alkene is the one in which the across the double bond the groups which are attached are of identical nature. Now if I would have taken this particular alkene, that is um, pentuene, pentuene. So here why what I would have said, this again is a alkene, but this would be said as unsymmetrical alkene, because on one side you have methyl, on another side you have ethyl. So this is unsymmetrical alkene. So here this statement becomes wrong because of the fact that here it is only un is written, making this statement wrong, and this wrong statement is answer to this question. So the answer to this question would be a D option. I hope you have understood today's session, where we have talked about what is the role of potassium bromide, Lindlar's catalyst, ozonolysis, and how aldol product is to be made in a speedy way. Thanks a lot. Have a nice day. In some other video, we will be doing some more reagents, so that you could slowly and steadily learn all of these information regarding to reagents into your knowledge bank. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.